All right. Welcome to Computer Science 164. So before we dive in with an overview of what the course will be about this semester and a bit of material in this first day, I thought I'd give you a sense of how we spent last night. It's not so much a server-side challenge we faced, but a client-side one. So have any of you discovered this particular website just yet, or Canvas, which some Harvard courses are now moving to? So iSites is about to die a slow death. If you've gotten attached to it, it's likely to be replaced with Canvas. And so we thought we'd jump aboard and be part of this beta test using Canvas, which is an open source tool. It's sponsored by a company called Instructure, so there's a corporate backing behind it. But for the most part, we're using it in this way. But last night when we were trying to get the course's website finalized, we ran into a lot of frustrations because this is a learning management system, which means it's a piece of software with which you can manage content by using a web-based interface. You don't have to use arcane configuration files. You don't have to know anything about databases. It's pretty much point and click in the way Google Sites or something like that might be. But as a result, it was damn hard to do something simple like, let's go to the course's website now, just put menu options in this left-hand side. Case in point, there's nothing there actually right now because the way the software is designed is that if you want to install things in your left-hand menu, you have to actually install these modules or applications in the software. And we didn't want to do this. We just wanted a link to like the syllabus. We wanted a link to the staff. We wanted a link to videos and the like. So if you were faced with a website, some third-party website, over which you have no control over the source code, you have no access to the server, you can't SSH, you can't SFTP, all you can use is the local web interface, and you want to start changing or altering the user interface via other means, what might your first instinct be? What questions might you ask of Instructure, in this case, the company, so that you can kind of work around these limitations like we did? We want to add menu options, but we can't change their server code. So what solution might that hint at? Yeah?
You might think about something like a Chrome extension.
OK.
Alter how things show up on your client.
Yeah, so we could consider something like a Chrome extension. If not familiar, a Chrome extension is essentially a piece of software for the Chrome browser, generally written in JavaScript. And it's just a way of injecting code, typically JavaScript, maybe some CSS, into a web page that you visit, whereby the Chrome extension is just constantly monitoring what websites you visit and trying to detect, oh, if you're on Facebook.com, do this. Oh, if you're on isites.harvard.edu, do this. So those of you who might have used CS50's 2x plugin that allows you to speed up videos is exactly that. So that's interesting, and that's kind of on the right track, because if you don't have access to the server, yet you want to somehow change the DOM, the tree that the user is seeing, you can pretty much only do it client side. Now, of course, an obvious catch of using a Chrome extension is what? Right, so not everyone's using Chrome, and it feels kind of lame if you sort of have to mandate that all of your users can only use the website and see menu options if they have Chrome. So what else might we want to ask Instructure?
So one thing is, I guess you can probably edit the text on the website, right? So you
OK.
can find out if you can actually put HTML in the text.
OK, good. So we could ask them if we could put HTML in the actual text. So rather than just post a textual announcement, can we add links? Can we add images? Can we add bullets? Anything that we might want to do aesthetically. And the short answer is yes. There is indeed a sort of WYSIWYG, what you see is what you get, editor, that comes with this particular piece of software that allows you to edit things like the home page with my name and Rob's and Tim's and so forth. And that got us part of the way there. Unfortunately, that doesn't let us put anything here, for instance. That doesn't let us put anything here because we're constrained by what the original authors wanted us to do. So we're one step closer. What else might we ask the company? What are the other workarounds, perhaps? This has got to be solvable. What else might you do? So you were on the right track with this notion of client-side JavaScript injection. How else might we get JavaScript into the site, perhaps? Right? Because once you have JavaScript, you can pretty much do anything. Even if your experience with JavaScript is limited to 50 or some other prior experience, you know that you can traverse the tree that is a web page, the DOM. You probably recall that you can add nodes or remove nodes. You can inject things into a web page. In fact, that's exactly what the CS50 2x plugin does. It rips out the iSites video player and puts in a different one altogether. So what if the company in structure allowed you to inject JavaScript into your course website? In other words, what if they allowed you, via their GUI, their WYSIWYG interface, to paste the URL of a JS file and maybe even a .css file, and then they took care of the process of inserting it at the very top of every page? So sure enough, this was the only way we were able to achieve this. If I view the page source here, and let me zoom in and search for cs164.net, which is a domain we, the course, own, notice that via some series of steps, it took a while to figure out with their documentation, we were able to say atop every web page that Canvas outputs for this course output that CSS file. And if we do another Command F and search a little further, you'll see that down here, nested within some JavaScript code, there's also mention of this URL here. So in other words, we sort of have tricked them into injecting whatever CSS, whatever JavaScript we want into the website. So that then begs the question, what does it do? Well, let's go ahead and just grab this source, paste this up here. It's forbidden because to simulate this, I chmoded everything. So let me give that back read access and now reload. So what did we do? So you'll get better at this, particularly mid-semester when we spend a lot of our time on JavaScript. But what does this appear to be doing? So one at the very top of this JS file, which again is included in every web page that the course now runs on the website, we check to see if the type of jQuery is not undefined. So in layman's term, what does that mean? What would it mean if jQuery is undefined? Well, you do have JavaScript loaded. You don't have jQuery loaded. So we're just hoping that in structure, the company actually is using jQuery themselves. Otherwise, we would have had to paste the jQuery library on top of this file so as to have access to it. And this is because I simply want to have access to things like the $ notation and other functionality that comes with jQuery, if you recall this library. And if unfamiliar, or if it's been a while, rest assured we'll come back to this within a few weeks' time. So what are the things we're doing here? So for those that might recall, what does this syntax here mean when you just pass an anonymous function or lambda function in CS51 speak to the jQuery function like this? When is this code going to get executed? Yeah? Exactly. So this code, by nature of this default function call, is only going to get executed when the DOM, so to speak, is fully loaded. All of the HTML, top to bottom, left to right, has been read into memory, and there's some tree structure inside of memory. Now, this is good because if I want to start playing around with it and changing the menu options, removing things, adding things, I better wait until at least the default DOM is in place. So this is just standard jQuery syntax. It's equivalent to saying when the DOM is ready. And now it's really just a combination of jQuery syntax and some HTML. So for instance, I decided that this was just bothering me. No one on campus says, oh, are you taking comp sci 164 or comp sci whatever. You say CS 164 or CS whatever. So minor little nuisance. We wanted to change that. So how might we do that with something like JavaScript? Well, notice if I go to the page here, and atop the page previously was CS 164. If I open up Chrome, which is a useful browser for doing DOM inspections, and you zoom in here, notice that inside of this HTML was an element that had an ID of breadcrumbs, and that ID does what? It uniquely identifies one of those nodes in the tree, and as soon as I have a unique identifier for some chunk of HTML in the DOM, now I can do anything I want with this web page. I could delete every DOM node, every HTML tag from the page, and put anything that I want, but my needs were fairly humble. I simply wanted to, per the snippet of code here, I wanted to first find the section tabs header, which was one of the parent elements just above that, and I wanted to go ahead and change the contents of that via this HTML function to a link to CS164, and then I wanted to alter the CSS on it to have a font weight of bold. And we won't go into great detail on the rest of this here, but notice this line here. I did a global replace everywhere, essentially saying anywhere you see a span that has a class called ellipsable, that's not a standard thing, that's just what the Canvas software calls certain classes. If it contains the key phrase comp sci 164, go ahead and replace the HTML inside of any such span with just CS164. And the rest of this is fairly well commented, but at the end result, what I'm doing is manually, with Chrome or any browser, figuring out what the unique identifiers are, various DOM nodes in the tree, and mutating them in the way that I wanted. And the end result, now that we've chmoded things correctly, is that now I can put an arbitrary chunk of HTML over here. I can rip out things like the footer. I can rip out HTML over here. And I should wave a huge disclaimer. This is a complete hack to be implementing a website like this. But it sort of speaks to the thought process that should, toward the middle of the semester, especially when we spend time on JavaScript, get you thinking about how you can solve various problems. Hopefully better than in this way, but the ingredients for solving a problem like this really just reduce to some basics. Opening up something like Chrome's inspector and understanding what the DOM tree is. Knowing what the CSS selectors are for unique IDs or for class names. Knowing some syntax, whether it's in JavaScript pure or in jQuery, the library, to actually change the DOM. And at the end of the day, we're pretty much able to bend the software to our will. But there's probably a catch. What's the price we're probably paying for this complete hack? What's the risk? Yeah.
If Instructure changes the website, then your jQuery will break.
Exactly. If Instructure renames one of their classes or renames one of their IDs or just rearranges their HTML, which is totally their prerogative, all of this could break, and then one of us is going to have to notice it, or one of you guys is going to have to report it, and we're going to have to tinker with it again. So maybe not a huge deal, but still a threat. What else could happen? What else is bad about this approach? It's less common these days, yeah? It's a little slower in that rather than just get the original source from the server, you're now making additional changes client side. And indeed, if we had a somewhat slow internet connection, you would actually see most likely some flashes on the screen as DOM nodes are changing. We just happen to have a good connection, a pretty fast computer, and so it's fairly elusive to the user. But what if they have JavaScript disabled? Now, this is an extreme corner case these days. Most people are in the majority when they leave JavaScript on. But if it's off, what happens? Well, you don't see any of that whatsoever. So in short, relying on JavaScript for something like this gets the job done. But the takeaway is how we went about doing this. And you can see for yourself just by viewing the source and then poking around at any of the 2 URLs on cs164.net how we actually did this. But it's illustrative of how you can start building more interesting DOMs, and even in the case of dynamically driven websites like the Facebook application or GChat or the like that are constantly pulling in more data, how you can actually change that interface. But now, let's look at the right way to start doing things. So this year, the course, unlike 2 years ago, will be based primarily in PHP for the first half and JavaScript for the last half. Whereas 2 years ago, we focused more on mobile with a bit of PHP. This year, we decided to change things to focus more on web-based applications, implemented not in pairs of people, but in teams, specifically teams of 4. And the motivations were several, but among them were that with a team of 4, there's just a lot more pieces you can bite off as a group. Doing web development tends to lend itself to different aspects of the project that you can then delegate among your team. For instance, we'll likely have 1 or 2 of you in a given team working on the front end, the JavaScript code, the CSS, the aesthetics. On that same project, another 1 or 2 of you will focus on the back end, the database schema design, the validation of data, writing the API that the front end people will work. And so we just get a lot more breadth of opportunities for people to collaborate. And so you'll find if you've done projects with just 1 partner in the past, that with 4, it'll be a little more challenging, more interesting, but a lot more powerful to have all of you guys collaborating together. In terms of the prerequisites, we likely will stick with these per the catalog, 4 prior CS courses. And this is based on experience. A couple of years ago, as I alluded to earlier, we pretty much allowed anyone who took just 50 or maybe some class in high school to take the course, but there was just such a spread of abilities and comfort levels. It made it hard to have certain conversations, and a lot of students in the class struggled. So we thought this way we can sort of do everyone a favor collectively. So keep that in mind. In terms of the team, size 4 will be the default. If you have 3 friends with whom you'd like to partner, that's totally fine. We will not mandate particular teams for you. If you don't have any friends or partners in mind for the class, no big deal. We'll keep that in mind as well and try to facilitate those kinds of partnerships. In terms of the structure of the class, this is very anomalous. The course will not be structured for the most part around lectures and will not be structured around you guys sitting there staring this way and me talking this way. Rather, most of the class sessions will be in the form of team meetings. Either your team will gather here or elsewhere on campus for a couple of hours on Monday afternoons or for a couple of hours on Wednesday afternoons. In the coming weeks, we'll figure out which day and which time each folks will be. If need be, we can tweak the times, but we shall see based on a survey that you guys all ultimately fill out. What happens in these meetings? So the weekly meetings is where you guys primarily present the progress on various projects. More on those in a moment. So at these team meetings, one of the teaching staff and or myself will be present, and the goal will be for each of the 4 people on the team to report on milestones that you have or haven't achieved, where the milestone will be defined as researching something, implementing something, designing something, thinking about something, or the like, defending design decisions. So it's been meant, this class, to be particularly critical or challenging. So it's not just going to be talk about your day and how you actually chose to implement this, but I and Rob and Tim, who you'll meet in a bit, will be there to challenge you, so that if you made a decision and it is not necessarily the best, that's fine if you actually have a strong opinion as to why you did that. And an answer of the form, well, it works, but I'm not really sure, is not what's really expected at those meetings. So it's really meant to be a bi-directional conversation in which you defend your decisions and also convince us that the path you've taken is ideally best, or it's an opportunity for you to solicit feedback from us and even your partners as to what you might be doing differently. And then in particular, these will be opportunities for code reviews. So you guys will be writing JavaScript code and PHP code and other technical aspects of each project, and the goal will be in front of a big screen TV around a table like this for one of you to stand up at a time, whoever's been doing the most work on some aspect of the project of late, and to present the code and give us a verbal tour of the code and give us an opportunity to say, why do you have 6 nested loops implementing something like that? Or why don't you have indexes on your database table? Or various topics that we'll explore over the course of the semester. So occasionally, we will have technical talks. Either in the form of these in-person style meetings where we all gather together, or via video to make things a little more asynchronous for convenience's sake, on particularly technical topics and tools that we'll use during the semester. Some popular JavaScript libraries, for instance, are Backbone.js and Bookshelf.js and Express.js. These are all tools with which you can make web-based applications using JavaScript. Not on the client side, though, but on the server side. Using a framework called Node.js, which is an alternative to using something like Apache or Microsoft IIS or other web server software. So we'll actually write in the class JavaScript code, both on the client side as well as on the server side. We'll talk about tools with which some of you are already familiar, things like Git. We'll dive in deeper to things like SQL and constraints and transactions and a lot of the details that certainly in a class like 50 we kind of wave our hands at for time's sake, but are ever more important when actually implementing a project that's going to be used by actual and hopefully large numbers of users where performance is going to start to make a difference. In the PHP world, we'll use a framework called Laravel. This is an MVC architecture, if you know or recall that acronym. And it's just a bunch of PHP code to make a lot of jobs easier and to make it easier to write more complex software, particularly projects that are implemented by multiple people. For testing, we'll use tools like Mockery and PHP Unit, and we'll get into the habit of not just writing code and sort of banging on it and anecdotally trying to figure out does it work as you intended, but rather does it pass certain tests, so that especially if a friend of yours in your group changes some code, you can be sure that he or she has not broken anything simply by rerunning the tests that you've already written for that code, so that you don't have regressions to buggy states of software. In addition, the projects is where we'll spend most of our time. So there's no exams. It is all driven by projects in this class, and there will really just be 2 per team. Essentially, the first half of the semester, we'll focus on one PHP-based website that will have front-end user interfaces, both for desktop and optionally mobile. So this will be an opportunity, albeit tangential to the class, to actually do something like a web-based mobile interface, or if you're really determined, Android or iOS would be perfectly fine. Just realize that the learning curve there, if unfamiliar, would be a bit higher, but would play very nicely with the vision of also having each project have some back-end API, so that you can have a separation, an abstraction between what you are doing and what Alice and Bob and Charlie in your group are also doing as well, so that each of your front ends or back ends can somehow intercommunicate. In terms of the specifics, for the framework, we'll rely on Laravel and Eloquent, which is an ORM, an object relation mapper, which is just a layer of software that addresses the M in MVC, the model, and makes it a little easier, especially for large projects, to query data from databases and to write data and to represent real-world entities without having to write raw SQL code. In the world of JavaScript, we'll again use Express and Bookshelf, which are analogs in the JavaScript world, but using, instead of Apache, using Node.js, which is increasingly popular and allows particularly for applications involving real-time interactions, chat rooms, and the like. Node is much better than Apache when implementing projects like that. Because you can send messages using models like pub and sub, publish and subscribe, if familiar with those phrases. So more on that toward the middle of the semester. In terms of expectations, these are them for the course. Attend or watch these occasional talks, technical talks, the schedule for which we'll ultimately put on the course's website. Participate in all of the meetings, so attendance is required at each of the team meetings, because after all, that's where the most of the course's instruction and feedback and interactions will happen. Weekly milestones, we'll use a tool that I'll make mention of in a moment to generally assign you from one or two of the staff members to each of the 4 people in the group things to do. And those things will come in the form of, why don't you go vet this option? Why don't you go vet this option and figure out which of those 2 implementation possibilities are better between now and, say, next week? Why don't you go implement this? Or you design these database tables? And so in short, the schedule in the course is going to be fairly organic, depending on the projects that each team tackles, depending on what your findings are when vetting some implementation option, and depending potentially on what the end users ultimately want the project to do. And so toward that end, there are no fixed deadlines per se. There will pretty much be a rolling assignment of deadlines every few days, every week, based on the conversations that you have with 1 or 2 of the staff members at your table. Ultimately, though, what's due is the submission of these 2 final projects. In terms of what the projects will be either proposed and selected by you guys. In fact, on the lottery form, for instance, you'll be asked what are 1 or more projects, particularly that somehow relate to campus, that you think would be compelling to implement. Since one of the hopes for the course is that whatever projects do come out of this course survive the end of the semester. And so particularly if they're campus themed, whether if that's another course catalog, shopping tool, or events calendar, or shuttle service, or any number of popular final projects, the hope after the end of this semester is that any such project live on. And indeed, toward that end, what we thought we'd do is make it a little interesting and also sort of incite opportunities for debates, whereby for most any project that we as a class tackle this semester, there will be 2 teams assigned to that same project. The general idea being that they're not really supposed to talk about their various design decisions. Rather, it's meant to be more of a competition as to who can ultimately produce the best design implementation, so that at the end of the semester, come May, we ship 1 and not both of those solutions. And we as a course will take care of the hosting and so forth so that your legacy lives on at the end of the spring. What do these applications do? Can be anything, something for a department, something for a student group, something for students more generally. That'll be part of the conversation in the coming week until we dive headfirst after picking a handful of such projects. In terms of the staff, let me introduce Tim and Rob, who would like to say hello. And it's these guys who, for one of the projects, will be, for both of the projects, will be your primary advisors. Essentially, for one of the projects, Rob will be gathering with you weekly for these chats. For one of the projects, Tim will be gathering with you weekly for those chats, and we'll swap roughly mid-semester as we transition projects. If you'd like to just speak near to this microphone.
Hi, I'm Rob. I graduated last May from Kirkland. I'm preceptor in CS here now. Excited for the course.
And I'm Tim, and I'm actually completely new to the area. I'm originally from Philadelphia, so I just started up here a couple weeks ago, and I'm really into open source software. I help out with maintaining the Backbone.js project, which some of you might be familiar with, and I also created the Bookshelf.js project that David was mentioning. So I'm excited to see the projects.
Indeed. So for more information on Tim, at least, if you go to the course's homepage and click his name, it'll lead to his GitHub repository if you'd like to look at some of his open source tools and projects. So in terms of grades, just because this is an FAQ, even if sort of tangential to the bigger vision of the class, how will final grades be determined? So it will ultimately be fairly subjective, based on the interactions we have with you over the course of the semester, based on your contributions, both to code repositories and to conversations that we have. And in a nutshell, it will be based on your contributions to projects, the delta between the first week and the last week. So not to worry if you have only 4 courses under your belt, whereas some other students in the class might have 8. We'll certainly keep that in mind. The scope, correctness, design, and style of your project, so those familiar axes. The degree to which you prepare for meeting. So this really is meant to be an opportunity for us to gather weekly and have intelligent and fun and sort of ideally emotional debates at times where you guys do propose how you might solve something and then defend what you might do. And Tim's role and my role and Rob's role will be to challenge you, hopefully, so that either you can be persuaded to go off in some other implementation direction or can be confident and feel pretty good about the fact that, yeah, you think you have the best implementation possible for this, particularly insofar as there'll be another team working on that same project from their own individual angle. In terms of the tools, so this will perhaps evolve over time, and you're welcome to use whatever is of interest to you for your own internal team. But for the most part, we'll make use of a free tool called Asana for task management. You'll see more on this via email in the coming days, and it's essentially a tool via which you can have workspaces and projects for teams. So if your project is to implement Foo, your 4 team members will be inside of that project, that folder, so to speak, and you and we will be able to assign milestones and to-dos and dates and comments. And it's nice because it's integrated with email, so you can or can't visit the website. It's totally up to you. And you can also get an aggregate sense of what folks are working on and get a sense of what's going on beyond your own particular bubble if your head goes down after a while focusing on one particular thing. For GitHub, too, if unfamiliar, GitHub is one of the most popular, if not the most popular repository out there for source code these days. We'll use that as a central repository for each team of 4 so that you 4 and then we 3 have access to and can comment in the form of code reviews using GitHub's interface. But we'll introduce you to that if unfamiliar when the time comes. And that's just a quick glimpse at Asana, quick glimpse at GitHub. And now let me pause for any questions. Yeah?
What do you think of other frameworks such as Python frameworks or Ruby frameworks versus PHP?
Good question. What do we think of Python or Ruby frameworks? They could achieve the same goals in particular. We happen to use PHP in 164 because a lot of people's prior web experience is coming out of 50, which uses PHP right now. But absolutely, could any of these projects be done in Ruby, Python, even Java, or other frameworks? Node.js, certainly. But we happen to use PHP and we happen to use Node.js, and we want to standardize those for both of the projects so that it's a lot easier as a class to have very similar conversations and not have too many apples and oranges in the class, even though there will be discretion when it comes to the particular add-ons and libraries that you might use for either of those environments. So no claim that one is particularly better than the other. And PHP has a sort of an ugly history, but it's gotten much, much better in recent years. So what lies ahead? No homework or any such things tonight other than to visit this URL. If indeed of interest, we'll post the link on the website if you forget where that is. The deadline for this is going to be 6 p.m. on Wednesday so that Rob and Tim and I can sit down that evening and review the submissions and figure out how best to optimize groups and so forth. We'll let you know by Thursday whether or not we've had to lottery and if we have a spot so that you guys can get study cards signed or figure out what you want to do. And in the meantime, if you have any questions, go to the course's website, email staff@cs164.net. When we come back on Wednesday, it will still be this format, but likely starting mid next week or the week after, will we divvy up into much smaller groups with just 4 of you meeting at a time with me and or Tim and or Rob. Thanks very much to the team in back today. We will see you on Wednesday.